All right, today we're tackling something that trips up a lot of people, math word problems. We're going to learn how to translate them, essentially learning the language of algebra.
You know that feeling, right? You're staring at a word problem, and it feels like the words are just there to confuse you, not actually help you solve anything. It's less like math and more like a riddle in some kind of foreign language.
Well, here's the thing. You're not wrong. They really are written in a code, and that code, it has a name, algebra. So the real key here isn't just about doing the math, it's about learning how to speak this new language. So why even bother learning this code? I get it. It can seem tricky at first, but trust me, translating words into equations, it's an incredibly powerful and efficient way to solve problems, especially the really complex ones. It's like having a superpower, seriously. Okay, so every language needs an alphabet, right? In algebra, our letters are called variables. You've seen them, X, Y, N. They look kind of intimidating, but they're not. Think of them as just placeholders for a number we don't know yet. They're basically the who or the what in our math story. So once you've got the alphabet down, you need some vocabulary. And in algebra, it turns out that certain words and phrases in English translate directly into math symbols. So let's build up our little dictionary. Let's start with addition. When you see a phrase like, a number increased by 6, those words, increased by, that's your cue, it's your signal. It literally just means plus. So our unknown number, y, increased by 6 becomes, you guessed it, y plus 6. And hey, the same exact logic works for subtraction. You read a number decreased by 3, and that key phrase, decreased by, that's a direct translation for the minus sign. So our number, x, decreased by 3 is just x minus 3. Easy enough. All right, what about multiplication? If you see something like 4 times a number, you know you're multiplying. Now in algebra, we get a little efficient. Instead of writing 4 times s, we just squish them together, 4s. That number out front, we call it a coefficient. It just sits right next to the variable. And of course, we've got division. A phrase like a number divided by 2 is, thankfully, exactly what it sounds like. It translates right to our variable, n, followed by the good old division symbol and the number 2. Okay, so we've got our vocabulary down. But just like any language, algebra has grammar rules. And this is a big one. Sometimes the order of the words in the English sentence is not the same as the order of the symbols in the equation. Honestly, this is where most people get tripped up. Let's look at a really common tricky spot. The phrase, a number decreased by 8, that's pretty straightforward, right? It's x minus 8. But what about 8 less than a number? You might think it's 8 minus x, but it's not. It means the exact same thing, x minus 8. That little word than is the key. It flips the whole order around. You have to start with a number, x, and then you take 8 away from it. So what does that mean for us? It means we have to be more like detectives than just simple translators. We have to be on the lookout for those sneaky little grammar words, like then, that are telling us, hey, rearrange these pieces to get the meaning right. Okay, quick recap. We have our alphabet, those are the variables. We have our vocabulary, all those operation words, and we have a super important grammar rule about word order. Now, let's put it all together. Let's translate a full sentence. All right, here we go, the final boss. Let's translate a complete sentence. I know it looks a little intimidating at first, but don't worry, we have all the tools we need. We're just going to break it down piece by piece, just like a professional translator. Let's build this thing. First piece, 5 times a number. Okay, from our vocabulary lesson, we know that's just 5x. Got it. Next piece, decreased by 7. We just tack that right on to what we already have. So now we're looking at 5x minus 7. And the final part of the puzzle equals 13. That gives us the other side of our equation. And boom, there it is. We've translated the whole sentence into a perfect algebraic equation. 5x minus 7 equals 13. When you really get this, something fundamental just shifts. You're not just plugging numbers into a calculator or making wild guesses anymore. You're actually engaging with a problem on a completely different level. You start to see the hidden structure underneath all the words. You actually understand the logic. You're taking a sentence from one language, English, and translating it perfectly into another. You are speaking the language of algebra. So now, with this newfound fluency, the question totally changes. It's not, can I solve this anymore? Now it's, what's the next idea I want to express? So my question for you is, what problem will you translate next?